Hi, welcome to the Advanced Manufacturing Media webinar, Validating the Return on Investment for Intelligent Lifting Devices. My name is Sarah Webster, the Editor-in-Chief of Manufacturing Engineering. As an innovator and leader in the enclosed track world station crane industry, Gorbel has over 30 years of experience providing overhead handling solutions from 50 pounds to 40 tons to customers in a wide range of industries. Gorbel has a comprehensive line of crane technology products, ergonomic lifting products, and a line of TetherTrack stall arrest safety systems. Questions can be submitted and will be answered following this presentation. Our presenter today is Mark Grandusky, Product Manager for Gorbel Inc. Mark has more than 13 years of material handling experience and expertise. His knowledge of lifting technology is widely recognized in the material handling industry, having been called upon as an expert by a number of trade publications. Mark also served in the U.S. Navy from 1985 to 1992. And with that, we welcome Mark Grandusky.
Thank you, Sarah, and welcome everybody. Thanks for taking some time with us today to talk about intelligent lifting devices. What we're going to do today is talk about the intelligent lift devices with a focus on return on investment, or ROI. And I'll give you a little bit of a disclaimer first. I certainly work for Gorbel. We are the leading manufacturer of an intelligent lift device, and we certainly have motive to be selling to you. But my real passion is to get this technology out. And we're going to really focus more on the industry, the technology as a whole. So while I'm not here to necessarily promote the product, I'm here to talk about the passion of the technology and to discuss this technology from that level. So this is not a sales pitch, it's an educational piece, and I hope we all can view it that way. So I appreciate that. Moving on to the next slide here, we're going to get into the return on investment. So intelligent lift devices, or ILDs. This is the latest technology in lifting today. So we look at other alternative devices such as such as chain hoists and air balancers and vacuum tube lifter. They all have their place in the industry and have been used for decades. The intelligent lifting devices have been around since about the early 2000s. And there are benefits to these devices, and we're going to talk about that from the perspective of productivity, ergonomics, and the reduced product damage. So what is an ILD? So really the ILD does fill the void between those other alternative lifting devices, what I call traditional lifting devices, and manual lifting, or robotics actually. So the ILDs will use the human operator's intent and intelligence with robotic-like motion, productivity, precision to produce a task. So you get robotic-like speed and precision with the human in the control loop. And looking a little bit about the roots of the technology, this is kind of a fun fact, but Gorbel, this technology happened or started way back in 1998. Where one of our executives in a chance meeting with Professor Kazzaruni at UC Berkeley actually got this technology hooked up with Gorbel. And it was that's where things started. And the interesting thing is, this picture you're looking at is Sigourney Weaver in the movie Aliens, way back in 1986. And Professor Kazzaruni from UC Berkeley, his whole work is all about mechatronics and robotics and taking human motion or intent and transferring that to either something faster or something stronger. So if you've ever seen the movie Aliens, and if you haven't, by the way, check in on Netflix. It's not streaming on Netflix, but it is on Amazon Prime Video, so you can check it out there. But if you watch the video, you'll see Sigourney Weaver in this exoskeleton dock loading device. And she steps into this exoskeleton, she fights the alien in the movie. Well, you might think that's just a prop or a special effect. That was actually a real working prototype from Dr. Kazzaruni's lab at UC Berkeley, and that's really the kind of where the technology, the roots of the technology for the intelligent lift devices like the G-Force all started. So again, that started back in the late 90s is when we started to engage with UC Berkeley and Dr. Kazzaruni. And you see a picture here, this was in the mechatronics lab with one of his students, and you'll see one of our jobs was to take that prototype device that you see there in the lab and convert that into something that was very industrial and add the bells and whistles and the safety features that were needed to bring that to the industry. Here's another fun graphic. It kind of shows you, and this is the Gore-Bell timeline or the evolution of the product. But at the same time, there are other competitors as well that were marching through the kind of the same basic steps. Gore-Bell was first to market, but we were followed, but not far behind by other competitors. Right now, I can tell you that we do have the largest installed base, but the ILD technology is proven and available from multiple different vendors. So if you look back to about 1999, the first device you see there on the left-hand side, that was the UC Berkeley prototype. And then kind of evolving forward, we went through several iterations and really hitting a stride in about 2001, 2002, where we came out with our first all-in-one units. Prior to that 2001, 2002 timeframe, the actuator or the part that hangs from the rail system was actually a separate control. Or actually, it was just the mechanism that lifted, and it included the motor and the gearbox and the wire rope mechanism. And then you had to have this umbilical cord of control cables and a separate control panel. So it was big and bulky. It wasn't easy to implement into an application. But come 2001, 2002, we came out with our first model that was all-in-one, where we put all the controls and the control panel and the motor and the gearbox and all the mechanicals in one piece that could ride on a crane system overhead. So that's where things really started to pick up. And then from there on in, we came out with in 2003 with what we call the Easy Arm. That's an articulated form of an intelligent assist device. It's an all-in-one lifting package rather than having to have a overhead crane system and then a hoist-like ILD to run inside the crane system. The articulated arm, or Easy Arm in our case, is actually a very light ergonomic arm that's an all-in-one lifting package that includes the servo controls, the wire rope, the lifting mechanism, everything in one piece, and it's just one column in the floor. And then moving forward to 2008 and on to the present, we transitioned into our newest model, which is the QIQ lifting device, intelligent lifting device, and that is our current model platform. And we really did, if you go back from the period of about 2001, 2002 through 2008, we learned a lot of lessons. We were on that bleeding edge of technology. People were learning about the high speeds and the precision, the wire rope management, all the things that we learned in those years from about 2001 to 2008. We implemented into the latest and greatest QIQ model, and so that's one of the good things about Gore-Bell. This was a technology when we first started out that was unproven and untested. Now with thousands of units in the field and about 10 or 15 years experience behind us, we've got and in the industry in general, these have really come of age and are proven and accepted in the industry. So again, about the past decade, we've reached the broad acceptance kind of curve where everybody started to jump on board. So it used to be that anybody who was manufacturing ILDs 10 years ago was still pushing the product into the industry or introducing it to every customer. We were doing demos. We were trying to get the word out. But in the past, somewhere in the past 5 to 7 years, the curve really started to take an upward tick, and you saw a lot more big companies jumping on board, lots more material handling professionals in the field being trained and being aware of how to apply these. So that really kind of helped to amplify the acceptance of the ILD. So what sets an ILD apart, I guess? That's one of the big questions. As I talked about before, the ILD will mimic human motion. Whether it's in the form that you put it on a rail system, on an overhead crane system, or you take an articulated arm package like we talked about, this takes operator intent. When the operator engages the control handle and moves their hand up or down, this completely moves with the motion of the operator, so it does mimic human motion, and that gives you a lot of intuitive motion that is very different from pressing an up-down button on a hoist or opening, closing a throttle, a bail on a vacuum tube lifter, or pressing buttons. It's a very different, very intuitive, very precise feel, and much more operators seem to take to it much more easily. Again, we talked about it has high-speed robotic-like system. control system, and that's a servo control system. So the same type of control system that runs an arm type of robot this is basically a single axis of servo control motion. So you truly do get all the controls in the robotic-like precision and speed in an intelligent lift device without spending all the money and the guarding and the installation you would spend on an arm type robot. We also have a mode which we call float mode, and you'll see this in some upcoming videos, that allows the operator to disengage from the actual handle and to engage float mode. Float mode allows the operator to actually use their hand on the part itself, and with fingertip up-down force can float the load all the way up to the full capacity of the product. And with the Gorbal product line, that goes up from, we start out at 165 pounds, and in 4 different models, we go up to all the way up to 1,320 pounds. So you could have a 1,000-pound load or a 100-pound load and go into float mode and actually put your hands on the part itself, not on the control handle, but on the part, and exert upward or downward force and be able to float that load up to 1,320 pounds as if it were weightless. And virtual limits is another mode I believe you'll see in some of these videos. Virtual limits are limits that you can program into the intelligent lift device, that you can program start or upper limits, lower limits, slow down points in the stroke. And that's because of the servo control system that we talked about. So that robotic-like control system gives us the ability to do things like virtual limits. And also, because we have a very high-tech servo control system, by the way, which is very robust. A lot of people, especially in days gone by, like to think about these ILDs like a home computer on a rail system. That is not the case. These are very robust servo control industrialized systems, so they're very rugged. But we can integrate these control systems in with other process controls. So if you have machines, say machining centers or conveyor systems or anything you want to change the condition, maybe you want to inhibit the upward and downward motion of an intelligent lift device when a certain condition exists. Maybe you have a overhead chain conveyor and you don't want that chain conveyor to advance. If the G-force or the easy arm or any ILD is underneath that chain conveyor, you could actually feed a signal back from the line to the G-force or to any ILD and have it stop, slow down, only go up, only go down, only go to a certain point, or any kind of other customizable feature. And that is one of the other things that we come to is customizability. Because we run a program inside the industrial robust processor, we actually can customize these units. There's definite out-of-the-box functionality that we have, but you can customize that functionality as well for your application. And that is something that does not come with a traditional type lifting device. So let's talk a little bit about speed versus precision. So you get both. When you go to an intelligent lift device, you are getting both speed, the speeds of the top speeds of the Gorbal intelligent lift devices are up to 200 feet a minute. And that's in our lower capacity units. We have a 165 capacity unit that goes top speed of 200 feet a minute. Our 330 unit goes to 100 feet a minute. Our 660 unit goes to 50 feet a minute, and our 1320 unit goes to 25 feet a minute. So those speeds are pretty fast. Even at 1,320 pounds, 25 feet a minute is pretty darn fast for a load of that size. So when we first, I guess, looked at the speed versus precision, when we first started coming out with the intelligent lift device, we thought that we thought speed would be the thing that would entice end users and applications that were out there. And what we found out was quite the opposite. Most people are choosing a G-force or any ILD for the precision factor or the combination of speed and precision. Now we've got two types, and we kind of already covered this, but here it is on one slide. You'll have the rail mounted version, which on the right-hand side you'll see, that's an ILD that you would put inside of an overhead rail system, one of the Gorbal workstation cranes or any kind of rail system. We specifically have either standard trolleys that will fit in our rail systems or what we call universal adapters that allow you to have a plate that you can adapt to whatever crane system you might have in your plant. As well as the picture on the left there is the very lightweight articulated, what we call our easy arm, the articulated arm ILD. And you can have that in either an overhead mounted version or a column mounted version that would go on the floor. So let's talk about return on investment through productivity gains. So we talked about the increased speed. So in very plain terms, increased speed is just moving product from point A to point B faster. So that's where you get your increased speed. Users can work faster and maintain a higher consistency of productivity because number one, they will tend to use this device where a lot of times they won't use, they'll either kind of selectively use other traditional lifting devices because they might hinder them, but they're going to consistently use an intelligent lift device because it's going to move with their body, and that combined with the fact that when they do use it, they can move much more quickly. They're going to increase their productivity, and their stamina is going to be higher. Therefore, their longevity over the course of the entire shift or their work period is going to maintain a higher level of productivity. And then the precision side of the ILDs also facilitates higher productivity. So you can imagine if a worker had to perform a very precise task with a traditional lifting device that didn't facilitate a precision placement. Maybe think of an air balancer or a up-down electric chain hoist with a button where you have to jog or move a device up and down that is not very accurate, or it's not allowing you to put this part into a machine or do precision assembly application in a timely manner. The great thing about the G-force or any ILD is with the float mode, with the virtual limits, it allows you to actually increase your productivity because instead of waiting for that unit, that traditional lifting device to jog into place, which might take multiple tries, you can actually program the ILD or use the float mode to get right to the spot where you need it to be every time, very consistently, and to get that precision to match up with the productivity. So your the cycle time per unit is going to increase, and therefore giving you a better output. And then where you can take the applications, and one of the beauties of the intelligent lift device is that there are products out there, again, like we talk air balancers, very fast, but because an air balancer uses air to control the load, you get a lot of bounce and drift because of the compressibility of air. They're very fast, but they're not very controllable. On the other hand, you could go to a very slow speed chain hoist, which is going to give you relative precision, but with not a very fast cycle time. So the ILD kind of combines both the speed and the precision and the productivity gains through both of those factors and gives you an increased benefit. And then again, when we jump from another layer of productivity gain will come from the ergonomics and the faster movement that come with matching an ILD with a lightweight, all-in-one articulated arm package like the Easy Arm that we talked about from Gorbel. So this, you can imagine overhead. You've got a overhead crane system that has a 20-foot bridge, and you've got the actuator of the G-force is hanging from the rail. There's quite a bit of mass overhead. So if you have to make long traverses either on the rail system, on the bridge, or on the runways, you're either dragging the weight of the actuator itself or the weight of the bridge plus the actuator down the runways. So that's okay if you're making relatively smooth, controlled starts and stops, but where you have to move quickly from point A to point B, you're going to have a lot of inertia to manage in that crane system with the bridge and the device overhead. So when you go to a lightweight ergonomic arm like the Easy Arm, you end up putting the weight of the actuator back at the primary rotation point of the column, and you're only moving a very lightweight arm, the control handle, and the load itself. So you greatly reduce the inertia you have to manage of that load and of the lifting device itself. So this is a great ergonomic device because of its ease, but also because the operator is not having to move that inertia or manage that inertia in the starts and the stops. It allows them to be more productive. And then we get into yet another layer of productivity because of the intelligence of the ILDs. You can error-proof. You get into poka-yoke situations where you can create conditions either through standard out-of-the-box features using virtual limits or with customizable software that make your process error-proof. So you can use the intelligence of the processor to make sure that certain conditions exist before the next step of a process might be able to be executed. One thing that comes to mind, we did an application for a small engine manufacturer, and they wanted to make sure that they had to test the engine, but before they shipped the engine, they need to drain the oil out of it. So we gave them a kind of poke-yoke the situation where they wanted to lift up the product, weigh it, and then not be able to move that product down the line or lift it or lower it unless the oil had been previously drained out of it. So we were able to make a program that was able to sense the weight of an engine with oil or an engine without oil, and then make the condition of the drained oil out of the engine a condition for letting that device lift up and down to produce the rest of the, or to go forward with the application. So that was actually a really good kind of error-proofing application. And that's something you can do. You can think of a broad range of conditions that you could program in there, but the fact is you can use that processor as a part of the intelligence for the rest of your application. And we do give you, through, Gorbel has produced a study called the Ergonomic Lifting Study, and this is an excerpt from it, and this is the one that talks about productivity, and this is just one graph. There is a 4-page, if you go onto the Gorbel website, you'll be able to download this, and it is a 4-page brochure. If you want to request it, we have a 23-page full report on this study, and what we did was we measured the G-force productivity against the productivity of other lifting devices, other traditional lifting devices and manual lifting, and showed the gains that you could get. So this really helps you quantify some productivity gains where you could see in real numbers how much more percentage of product you could lift with an ILD based on other lifting devices or manual lifting. And when you go to the website, that's what you're going to want to look for right there. That is the front cover. And once again, that's just a 4-page white paper type of download for you. It's a real easy read, and it's got a lot of good information there. So let's talk a little bit about ergonomics. So just some rough numbers. And this is always a little fuzzy because until somebody truly experiences the cost associated with some of these injuries, it's hard to maybe wrap your head around that or for a company to justify it. But looking at some just general numbers from different sources, OSHA says that repetitive stress injuries affect about 1.8 million workers per year. And a government study put the cost of one RSI injury between the total injury pool of 17 billion and 20 billion a year. So that's a pretty big number. Now, how that breaks down to the actual per the worker per incident, and again, until you've had that injury and can quantify it internally for yourself, that's tough to wrap your head around. But I think we can all agree it is costly to have a worker out because of a repetitive stress trauma injury. So with the ILD, we do maximize ergonomic benefit. So certainly any device you're going to put in, whether it be a chain fall, an electric chain hoist, an air balancer, a vacuum tube lifter manipulator, they're all going to give you ergonomic benefit. If that operator uses that device, they're going to have an ergonomic benefit. They're not going to have the weight of that load they're lifting every day. It's going to reduce repetitive stress trauma injuries. However, the device is only effective. It's only as effective as it's being used. So what I'm getting at there is, depending on what your policy is for ergonomic usage, whether you mandate versus offer as an option to use, has a huge impact. So most companies that I've seen don't mandate. They recommend the use of a lifting device. So when you do that, you give the operator the option to use or to not use it. And a lot of times if it slows them down, that device will not be used by the operator because that operator wants to just get their job done. They tend to resist change, and they're going to do what they have always done, which is pick up that 40 or 60-pound part and just keep moving it all day long. So the ergonomic benefit you get with an ILD is definitely amplified because the operator does actually use the intelligent lift device because it moves with the motion of the human body. It provides the least hindrance to the human motion. So the operator is much more likely to actually use the device than they would be with a traditional lifting device. And we've seen that time and time again. So we're going to take a look at a quick case study. We'll look at a video here. And this particular one was a manufacturer of motor stators. And in this case, they're lifting 40-pound motor stators. And you're going to actually see two different videos here. But the first one we're talking about was for the motor stators into shipping containers. And then one was into, I believe, a press. And since replacing the manual lifting process, they have had 0 recordable injuries from this process. So let's take a look at this video. And also what I want to point out here, and we're going to probably talk about a little bit, a lot of time we end up getting to this in the question section, but one of the things I want you to look at here is the end effector tooling. Now Gorbel produces, and most ILD manufacturers will produce the lifting device itself, but a lot of times the solution is really made, the magic happens, I guess, in the end effector part of it. So in the way that you can get a hold of the part, in this one you're going to see magnets being used with a very customized end effector, but the point I want to make is when you go and invest in an intelligent lift device, you're making a significant investment to get a significant return. But if you kind of cheap out on the end effector portion of it and say I'm just going to use a sling or some chains or a hook, you will not, in many cases, unless your application is very, very simple, you'll get much more productivity increase, or much more ROI, I should say, a faster ROI when you invest in the tooling as well. Now, Gorbel doesn't sell that, so I don't have really an incentive to tell you that, except my experience shows me that the people who don't do that part of it benefit way less than the people who actually go ahead and invest in the end effector tooling. So make sure you take note of that in this application. Okay, so that was our video. Now, one of the things I hope you notice is, especially in that second half of the application, where the precision placement that operator is able to achieve with that reach-in application, and that was a direct result of the precision that we talked about that comes from that servo control system. So hopefully that was a really effective and eye-opening video for you. Now we're going to talk a little bit about decreased product damage return on investment. We did talk about virtual limits before, and again, this is one of the features in the ILDs. And I want to say that thinking back, Gorbel was one of the first to develop a full set of virtual limits. In our product, we offer upper speed reduction points, lower speed reduction points, upper hard limits, lower hard limits, and upper speed reduction points and upper resume points. So you can actually come and travel upward and this is basically to take off impact out of an application. So when you're going from a slacked wire rope condition and lifting up to putting a load in full tension, we allow you to actually slow down to get a nice soft pick and then resume speed. And you can program all those points very easily. And when I say program, I don't mean hook up with a computer to the lift device. We actually give you settable menu-driven LCD menu right at the handle, and you can lock that out from operators if you want to, or you can give them the access to it. It's your choice, but we give that to you right at the handle, so we're not requiring you to do any kind of programming. It's more of setting these points. And that's all available right out of the box on all standard units. And we talked about float mode. Float mode decreases product damage hands down because the float mode is a very precise, what we call hands-on part mode, meaning that when you go into float mode, you can take that 100-pound or 500-pound part, and with upward or downward force, direct contact on the part with the operator's hands, they tend to have a very good control of that part. They're very flexible and very nimble with that part, and they can place it exactly where they want it. And also another added benefit from the product damage side is because you're in float mode and you go to set that down on a work surface, you're never going to set that part down with the full weight of that load until you want to anyways. So what I mean by that is when you're in float mode, the entire load is weightless. The only force that load is going to impact the work surface with when you set it down initially in float mode is the amount of force that you're pushing down on that part with. So in cases where you might relate to an application where you're trying to hit a set of locating pins on a pallet in a machining center, and you bring that part down, you have to hit some locating pins, but maybe you're using a hoist, and you set the part down, the locating pins are not quite lined up, so the part sits on top of the locating pins, and then you have a slack chain, and then the operator kind of moves the part into position where the holes line up with where the pegs line up with the part, and all of a sudden that part, because of that slack chain condition or slack wire rope condition, that part would just drop right down, and you would impact the work surface with the full weight of the load. Well, with an ILD in float mode, if you miss the locating pins, you would just lift it back up and guide it back down with your hands on the part onto those locating pins, and that part would never see any impact on that work surface that's any greater than the amount of force you're pushing down with. So that's kind of a hidden benefit of float mode that people might not think of, but it's actually a very, very critical part in decreasing product damage, especially with highly polished machine parts and things like that where you don't want to scratch or mar a surface. We also offer in the ILD, and this is a feature that we offer at Gorbel, and this is again settable right through the LCD front control panel, but technically all ILDs would be capable of this, whether they have it as a standard feature or a standard feature, or you would have to go to the next step and pay a customizable fee to get that in the software. All ILDs would be capable of this. We happen to give it to you out of the box as a standard feature. And what electronic load limiting is out of the factory, there's a load limiting that it's an electronic load limiting, so there's no mechanical parts that can wear, like a slip clutch or anything like that. This is all done through load cell electronic sensing of the load. And out of the box, if you have a 165-pound capacity unit, that unit's going to overload on capacity just over 165, so we don't damage the equipment, we don't lift things that are beyond the capacity of the unit. However, that same safety and protection feature, we can actually take that and we give you the feature of limiting that to a lower level. So the reason we do that is, say you have a conveyor with attached pallets to the conveyor, and you've got a 50-pound load that you're trying to take off of the conveyor, and there are locating pins or some sort of feature on the pallet that are holding the part to the pallet, and if you don't pull it off just the right way, it might bind up and rip the whole pallet up off the conveyor or lift the conveyor off the floor. You don't want that to happen. You could actually take any unit and ratchet down the overload from full capacity down to, say, 50 or 55 pounds for a 50-pound load. So what that would effectively do is make it so that if your operator tried to lift that part off of that pallet, they could only lift with the amount of force equal to or just a little bit over the force needed to lift that part off of the pallet. And if it encountered any greater force than that, it would stop all upward motion, protecting your conveyor and your conveyor pallet. And that can be for any machine. So machining centers, protecting cutting tools, protecting the vertical pallets on a machining center, anything like that. So that's a very big feature that both protects your product and protects your machinery as well. And going back to the intelligent lift device, the ergonomic study that we talked about on the Gorbel website, this is another graphic from that study that shows how we quantified product damage incidents as with using a G-force and then using the other devices, traditional lifting devices and manual lifting, and you can see there is a quantifiable difference with the G-force. And one note about this study, we probably need to rerun this study in current days, but way back when we ran this, it was in the early 2000s, and this was before we actually had virtual limits as a feature with the G-force product. So if we reran this study today, this number would actually be quite a bit lower, pretty close to zero, I can say with confidence. But even without that, this is a pretty compelling story and a good way for you to help quantify what your ROI might look like. Okay, let's take a look at another case study. This is going to be, we're going to look at a compressor turbine manufacturer. So you're going to be looking at an impeller blank. And the one that you see is a relatively small size, but they had varying sizes of impellers. And so they went from a blank impeller without the fins machined on it to a fully machined impeller. So they would install this in here. You're going to notice there is a much simpler end effector used on this. It's just a three-prong non-powered grab, but it was pretty effective for this particular solution. Notice here you're going to see the operator using the float mode, and you're also going to see how the precision helped them to both lift and lower the part and to keep the operator's hands off the very sharp impeller blades after the machining process took place. So we got safety advantage, ergonomic advantage, and reduction in product damage. So go ahead and run the video, and we'll meet you back on the other side. Okay, I hope that was another effective, eye-opening video for you. What we're going to do now is we're going to kind of recap here, and we'll go into a little bit of a question and answer session here. But first, do a little bit of a recap. So in this webinar, we talked about kind of the roots in of the technology and the timeline where this all started. We talked about the current technology. We talked about productivity gains and ergonomic gains and decreased product damage gains and how they affect to the factors that impact ROI. And we looked at a couple of pretty good case studies that I hope are really beneficial for you. Just to let you know, Gorbel.com has a lot of good resources, a lot of good information available to you, and that you can get there by going to Gorbel, Gorbel.com. And while you're there, we do have what we call a ergonomic lifting evaluator. So this is not perfect, but it's kind of a good, fun tool to use, and you go in and you plug in your application specifics, and it'll help give you a general idea of what kind of the relative magnitude of impact an ILD may have for you in your specific application. So with that, I'm going to turn things back over to Sarah. Once again, this is Mark Grandusky from Gorbel, and I really appreciate you attending today. Have a great rest of your day.
Thank you so much, Mark, for that informative presentation. Again, I'm Sarah, the Editor-in-Chief of Manufacturing Engineering. And before we get to your questions, if you have any questions about our webinar series, you can reach out to me directly at swebster@sme.org. And now, with that, it's time for your questions. We're going to start with one. What is the maximum load this type of lifting device is capable of?
Okay, so for ILDs, for the Gorbel side, I say effectively, now you can go beyond 1,320 pounds, and Gorbel certainly does sell up to 1,320 pounds load. Some of our competitors may go a little bit higher, but right around that point right there, about 1,000 to 1,500 pounds is right where the ILDs kind of top out across the industry. One of the things I can tell you is we sell many more, and this is more of a light ergonomic lifting, and most of the benefit is really seen generally in the lighter end. We sell much more of the lighter capacity 165 units than we do as you go up the line. So you step from our volume in 165-pound units is higher than we have for the 330-pound units, and the 330-pound units are higher than the 660 units, and the 660s are more than the 1320s. So as you go up in volume, up in capacity, the volume actually goes down. So really the meat, the sweet spot for use in ILDs is really in the lower end capacities.
Before we get to the next question, I'd like to just remind you that you can click in your Q&A box and submit a question if you have one. In our next question, are there any ILD devices for up and in, as in into an oven or into a cabinet?
Yeah, the answer is yes, and any ILD can be used for what I call a reach-in type of application, where you have an overhead obstruction, or even applications like, it's a perfect example of an application is an oven, where you have a very tight spot where you don't have a lot of room in between the bottom obstruction and the top obstruction, and not a lot of room to drop a wire rope or a chain down to get directly in there. So the way that's dealt with is normally, as you saw in the video, the end effector tooling, that's where that comes into play. So you would, if you remember that motor stator video that we watched, where they had the piece, the magnet that gripped the motor stator and then tipped up, that gave you about a 2-foot reach into that press, and that press is another good example. There's minimal space in there, but that end effector with a rigid column gave you the ability to reach in. So the ILD itself does the up-down lifting, provides all the precision, provides all the speed and the virtual limits in the flow mode, but the end effector part of the solution, and when I say end effector, is that piece of the solution that actually grips the product and allows you to lift it with the ILD, but the end effector tooling is where you build in that reach-in capability.
Our next question, is there a way to see a local demo of either unit?
Yeah, definitely. I love that question. I travel around the country quite a bit myself. I'm out there with our different representatives, and we have by far the largest field population of demonstration units available of anybody. So wherever you are, we've got either a direct factory employee from Gorbel that has one in their territory, or one of our distributors that owns the unit for demonstration. So you can actually contact myself, call into Gorbel, call your local distributor, and we can absolutely set up a demonstration. We do that very often.
We have another question. Do you have rotating capabilities like turning an object over?
Yeah, actually, turning an object over, definitely. That's something that gets taken care of in the end effector side of the solution. And again, Gorbel doesn't manufacture that end effector solution. However, we have a strong partnership with a lot of companies who do, and the Gorbel distributor who you would work with, that's our point of sale. We work through a network of distributors, and that distributor would be able to put the entire solution with our partner, our end effector tooling partners, and our manufactured ILD product, and give you a total solution that would allow you to clamp that part or grip it in whatever way. It could be magnet, it could be vacuum, it could be an ID grip, it could be an OD grip, pneumatic cylinders, it could upend, it could rotate in the vertical plane or the horizontal plane. So we provide all of that. And while I'm on that subject as well, one of the real key features that we offer that's pretty exclusive to the Gorbel ILD is we have what we call the G360 collector. And the G360 collector, and this doesn't have necessarily, doesn't help you to flip the part, but it allows continuous rotation of the handle underneath the coil cord. And the reason that's important is because it minimizes downtime. Any device that you have on your plant floor, whether it be an air balancer with an air coil around the chain, or an ILD like a G-Force where you have the electrical cable and maybe even an air coil for your end effector tooling, our G360 exclusive collector allows continuous rotation independent of the air and electric cord that carries all the signals. And what that does for you, it keeps that from getting tangled and maximizes your uptime. So without having that G360 collector that's part of the G-Force and Easy Arm from Gorbel, you will have the potential to twist that coil up, and as operators an operator will tend to pick a part up and at one point drop it off 180 degrees on the other side of them and continue a 360-degree circle in a continuous rotation. So until we came out with that G360 collector, the solution to that problem was to train the operators to go back in the direction they came in the circle that they kept turning in. But if operators didn't do that, you would end up with coil cords broken or air hoses pinched and entangled, and that equated to downtime and replacement parts. So now we see very little of that ever happening unless something becomes cut or crushed from an outside force. Coil cords and air hoses last forever with that G-Force 360, the G360 on the G-Force.
We do have a lot of questions here. Before I get to the next one, if we do run out of time before we've answered your question, we will forward those to our sponsor and they will respond. But our next question, are there any, do your devices adapt to current jib cranes with chain hoists?
Yep, absolutely. As I said, we, because we manufacture, Gorebaum is the leading North American manufacturer of overhead rail crane systems and jibs. We certainly have our standard product has a trolley that fits all the Gorebel rail products. If you chose to buy a Gorebel workstation crane or a jib with the G-Force, it would come a match set with right wheels and trolleys, and everything would be good to go, and you'd install it. If you decided, however, that you have an existing jib you'd want to reuse, we have what we call an adapter plate. It simply gives you a couple of holes, and your distributor, most likely your installer, would fabricate an adapter plate between the holes in the plate that we give you and the trolley for the jib, and you'd be off and running. So we can go either way. We provide flexibility for mounting the G-Force to any type of platform.
Another question here, are there any limits to customizing the gripping portion of the ILD to better conform to the piece that is being gripped?
Yeah, and that again, that goes to our really strong network of end effector partners that our distributors would utilize to come up with a customized solution. End effectors, for the most part, and again, the end effector, when I say end effector or end tooling, those are both synonymous, and they mean it's the part that you actually, it's a custom piece that attaches to the ILD or any lifting device that allows you to grip the part that you're lifting. So that could be a magnet, it could be a clamp, it could be a vacuum if you're lifting, say, glass or granite or sheet steel that's non-ferrous. So there's a variety of ways you can grip, and sometimes you can, in that same end effector, it can upend and rotate or flip to facilitate the process, moving the part from one orientation to the next. But yeah, so it's really in the end effector design that takes place. But I will say that every application tends to be a customized solution with the end effector. So it is a little bit of a process. You will need to provide your local distributor with specifications on the size, the weight of the load. If you can provide an actual sample piece of the part that you want to lift to your distributor, they'll create a custom end effector for you. So that's all part of the plan and the total solution.
For the freestanding units, what are the floor requirements for anchoring, as in the thickness of the slab?
The thickness of the slab, standard 6-inch reinforced concrete is the standard. And that's for all easy arms. Right now, well, actually, I'll give you a little bit of a preview. We will very shortly be rolling out a 660-pound easy arm. Right now, our current capacities go 165 pounds and 330-pound capacity. But in the next month or so, we're going to be rolling out a 660. The 165 and the 330s will both bolt directly into a standard 6-inch reinforced concrete floor. Once you go to the 660 unit and you break and you get beyond a 10-foot span, that will require a foundation. If you're under a 10-foot span with our 660, we're going to be rolling out shortly. If you're under 10-foot span or up to a 10-foot span, you will be foundationless, and you can go right into a standard 6-inch reinforced concrete floor as well.
Again, we do have a large backlog of questions here, and we will make sure all questions get answered, but I think we're close to our final question here. What is the ballpark price of your units that you talked about today?
Well, it depends on what unit we're talking to, but I talk opening price points. So an opening price point on a 165-pound model for the G-Force, the rail-mounted G-Force product, is around $9,000 to $10,000, depending on options. And we are, by the way, with a pretty drastic amount, the lowest opening price point competitor on the market when it comes to that device. When you transition over to the light articulated arm product, you're looking at opening price points of around $12,000 to $15,000. And that does not include the end effector part of it. And just so you know, we talked about investing in the end effector tooling. Again, Gorbella does not manufacture it. That's your distributor will work with one of our network partners for end effector tooling. But you could add. So there are times when at the end effector tooling, depending on what it needs to do, if it needs to upend or rotate, if it becomes complex, there are times when the end effector tooling can be equal to the price of the G-Force or Easy Arm itself. So do be prepared for that. When you start talking about that total solution, it can get the end effector tooling is not an inexpensive solution.
And with that, we're going to say that was our last question. We appreciate all the engagement for you guys out there today who have questions. Anything that hasn't been answered will be answered by Gorbel privately. Again, thank you for joining us for Advanced Manufacturing Media's webinar. Our group, SME and Advanced Manufacturing Media, can help you keep abreast of developments in manufacturing. Our October issue of Manufacturing Engineering Magazine takes a special look at shop floor solutions. Advanced Manufacturing Media delivers the latest news and in-depth technical information online at advancedmanufacturing.org. Our automated manufacturing and assembly community, manufacturing community, features member discussion news, webinars, and more. Visit sme.org/AMA for more information. We also hope to see you at our upcoming SME events. We have South Tech coming up October 27th through 29th in Charlotte, North Carolina, and FabTech November 9th through 11th in Chicago. Thank you again for your time.